So, today we're going to be discussing prisms. But before we do that, I want to recap what we learned about spheres. I can take this cylinders. I can take this 3D object cylinder and unfold it to make what is called a net. Again, a net is a two-dimensional representation of a 3D object. And we can use the net to help us find two things, the lateral surface area and the surface area. The lateral surface area refers to the area of this portion of the shape, everything except for the bases. Whereas the surface area refers to every surface, including the two bases. With that in mind, let's discuss what a prism is and what its nets look like. Here we have a triangular prism. Now, before we get into the notes, I'm going to give you a very informal definition of a prism. And when we get into the notes, you'll get a more formal one. The informal definition of a prism is basically taking any two-dimensional shape, in this case a triangle, and stretching it into the third dimension. And this can happen with any shape. I can make a rectangular prism by taking a rectangle and stretching it into the third dimension. I can draw an octagon and stretch it into the third dimension. Heck, I could even take a circle and stretch it into the third dimension. When I do this, this is called a cylinder. So technically, everything we learned about a cylinder is true about prisms. We just didn't know it yet. With that in mind, let's discuss their nets and what the lateral surface area and surface area looks like. Here, I have a drawn picture of the net of this rectangular or triangular prism. If you want to see it without the scribbles, the net would look something like this. Finding the lateral surface area would be finding the area of this portion of my net. Whereas finding the total surface area would be finding the lateral surface area plus the two bases. With that in mind, there are actually fairly easy formulas we can use to find these without having to find each rectangle individually. And that's what we're going to be going over today, as well as the volume of these shapes. Let's try it out. So here's that formal definition I was talking about. A prism is a three-dimensional solid with two bases that are congruent and parallel. What that means is, in this case, this is a triangular prism because the triangles are both congruent and parallel to one another. That means that these triangles are my bases. With that in mind, let's discuss the formulas. The formula for the lateral surface area is perimeter times height. Perimeter specifically being the perimeter of the base. For the surface area, my formula is very similar to the lateral surface area, perimeter times height. We just need to add two bases. Now, this is not the first time we've seen this notation, but I want to reference it again. Big B refers to the area of the base. We saw this when we were talking about cylinders. The area of the base at that time was pi times radius squared, because my base was a circle. Now, however, my area, or the base, can change. It could be a circle, it could be a triangle, it could be a rectangle, it could be a trapezoid. It could be any number of shapes. So big B is going to be changing quite a bit throughout this exercise, depending on what your base actually is. And finally, volume is the area of the base times the height of the prism. In this case, that would be the height of my prism. With those formulas written down, let's try and do an example. Example number 1. Our first goal should be to identify what the base of this shape is. Now, rectangular prisms are special in that really any of the sides you choose could be the base because each side has a congruent and parallel partner. For instance, this bottom piece is congruent and parallel to the top piece. Same with the front and back pieces. The front piece here is congruent and parallel to the back piece here. For the purposes of today's notes, we're going to consider this and this to be the bases, simply because that's what I've done the math for. The only thing that will change based on what bases we choose here is the lateral surface area. The surface area and volume will still give us the same answer regardless of what base we choose. With that in mind, once I've decided what my base is, I always find it to be a good idea to draw myself a little two-dimensional sketch of it. The bottom of my base is going to be 7. The side of my base is going to be 9. Once I have that, I want to write down the formulas we're going to be using so that I know what I need to find. The lateral surface area is perimeter times height. The surface area is perimeter times height plus 2 times the area of the base. And volume is the area of the base times the height of the prism. So looking at my variables, all I need to know is the perimeter of my base, the height of my prism, and the area of my base. I'm going to start by focusing on these two first, because these two deal specifically with my base, and then we can discuss the height of the prism in a moment. The perimeter of my base is as simple as adding up all the outside edges. 9 plus 7 plus 9 plus 7. That gets me 32. For the area of the base, because this is a rectangle, my formula is going to be base times height. Again, because this is the area of my base, I'm not looking at the 3D figure. I'm only looking here at the 2D figure. The base of my 2D figure is 7. The height of my 2D figure is 9. So I do 7 times 9 and get 63 feet squared for the area of my base. Now the height is the part that tends to trip some people up, just because of the way it's called height. What we should do is we should picture this object sitting with the base downwards. So I'm going to redraw it real quick to demonstrate what I'm talking about. Here's a nice little rendition of what it might look like standing upwards, with 7, 9, and 13. If we picture it in this orientation, it becomes a little bit more clear that my height is going to be the 13, not the 9 that people typically assume it is. That's because, again, we want to picture this sitting on its base, whereas here it's sitting on its side. If it helps, think of this h as the distance between my two bases. The two bases are 13 feet apart, so my height is 13 feet. Once I have everything, it's as simple as plugging them into the formulas and letting the calculator do the rest of the work for me. The lateral surface area is perimeter, 32, times height, 13, which gets me 416. And the unit is feet squared because we're dealing with area. The surface area is the lateral surface area plus 2 times the area of the base. When I plug this in, I should get 542 feet squared. Again, we're squared because we're area. Last but not least, volume is the area of the base times the height, which gets me 819 feet cubed this time. Cubed because we're volume, we're in 3 dimensions now. All right, we're going to move on to example number 2, but the steps we follow are 1, identify the base, 2, sketch your base, 3, find each variable, And finally 4, plug it in. With that in mind, let's try out example number 2. Example 2. This time I've got what's called a trapezoidal prism because it looks as if I took a trapezoid and I stretched it into 3 dimensions. With that in mind, we should try and figure out what our base is. Remember, our base needs to be parallel and congruent. So looking at this shape, I've got a set of parallel sides here and here. But these 2 planes are not congruent with each other, so those aren't going to be my bases. Instead, the only set of faces here that are both parallel and congruent are the front and back trapezoids. And as a result, we should try and picture this as sitting on the face of the trapezoid, with the face down. I'm also going to go ahead and draw my 2D representation of my base, with the bottom being 23 feet, top is 18, the side here is 12, and the slant is 20. Now that I've got that, let's go ahead and write out the formulas so we know what I'm trying to find and how to plug it in. Again, I'm going to need perimeter, height, and the area of the base for all of my things. Perimeter and base we're going to do first because it deals with my 2D sketch, and we'll ignore the height for a moment. The perimeter is just adding up all the outsides of my shape. 18 plus 20 plus 23 plus 12. And I end up getting 73 feet for my perimeter. The area of my base is going to be the area of this trapezoid. Now, because this is a trapezoid, I have to use a different formula for the area of my base. The area of a trapezoid is base 1 plus base 2 times the height divided by 2. Looking at just my 2D figure here, this would be base 1, base 2, and my height. Base 1 plus base 2 times the height divided by 2. Which, when I plug into the calculator, I should get 246 feet squared. Last but not least, I need to find the height of my prism. So now we're looking back at my 3D shape. Remember, we can think of this as the distance between the bases. So if my base is here and here, I need to find the distance between the 2 bases, which in this case is 15. So my height will be 15. Now that I have perimeter, height of my prism, and the area of my base, let's plug things in. Perimeter times height, 73 times 15, is 1,095. So my lateral area is 1,095 feet squared. The surface area is going to be the lateral surface area plus 2 times the area of the base, which when I plug into the calculator, I should get 1,587 feet squared. And last but not least, my volume is the area of the base times the height. And I get 3,690 feet cubed because now we're talking about volume, and volume is always cubed. With that in mind, I hope that adequately explains it. If it doesn't, feel free to send me an email or leave a comment, and I'll try and respond as soon as possible.